Naming type 1 ionic compounds, and it's going to be awesome because they are fun and easy. We're going to take a look at, let me maximize my screen there. We've already looked at ionic bonding formation and how ions will form, and there's a very simple trick and easy way to do this. But first we have to know about a couple of definitions. So we need to first know what an oxidation state is. So an oxidation state is simply just the charge. So now all of this naming system goes under what we call the IUPAC system. That is our naming system. Stands for the International Union of Applied and General Chemistry, and we call that the IUPAC. I know the acronyms don't match up well, but we can find the charges quite easily because this one is a +1 charge. That's the reason. The reason for this is because these group 1s in group 1 all have valence electrons of 1. So all of these have 1 valence electron, so they're likely to lose an electron to get an octet or a full outer shell. If lithium loses an electron, it will have a noble gas configuration of helium. So it's going to want to lose 1 electron. So if it loses a negative charge, it is going to be positive. So that's why it's a +1 charge. So now this has 2 valence electrons, so the oxidation state of this group is +2. Now these have different valency and can have different oxidation states. These are type 2 compounds, and we'll look at those in the next video. These guys, though, all have 3 valence electrons. That would be a 3 up there. So these guys are going to be +3. They're likely to lose 3 electrons and and have a +3 charge. Now these guys over here have 7 valence electrons. So they are likely to gain an electron and try to get 8. So the halogens are going to be a -1 charge because they're likely to gain 1 negative charge, so they'll be -1. These will have 6 valence. Oh, I should have just done these in order. But 3, 4, 5, 6, 7, 8. So this one has 6 valence electrons, so it is likely to gain 2 electrons, which means it would have a -2 charge. And this has 5 valence electrons. It's likely to gain 3 electrons, so it would be -3. Now, in the middle, we have kind of a rule, an impasse right here, where we switch between positive and negative. It's almost like a 50-yard line, where you have we have this palindrome thing, where this would be a -4 or a +4, but that doesn't really tend to be an issue because these are mostly covalent bonded. So simply what I will just say is I will use the word oxidation state, but all you have to do is just remember that it is the charge. Now, let's take a look at the rest of the notes. If we look at the cations are things that have, let's see, it only has 1 oxidation state. And a good example of that would be sodium. Sodium will always be a plus charge. The 1 is understood, so we'll just call it sodium plus. Or if you could say barium, barium 2 plus. It will always be a 2 plus. So those were always going to be positively charged because cations are positive. Okay? Because a cat has pause, so it's positive, right? Now, a type 2 one is going to be one that we'll look at later, but it has more than 1. We will look at examples of those later, but you really don't have to mess with we're not going to mess with that. So now for the naming. of type 1s. For type 1, we are not going to change it. So no change at all. If it's going to be sodium chloride, the sodium still says sodium. Okay. So you'll see what I mean in a second. Now for the anions, these are the negatively charged. So negative. They're the negative ones. And they have a little bit of different naming. So the naming is, we're going to change the ending to "ide." So for example, fluorine, remember fluorine has the flu, okay, so you will spell it correctly, will be changed to fluoride. Chlorine goes to chloride. What about iodine? Iodine goes to iodide. Phosphorus, phosphorus, O-U-S, sorry, gets changed to phosphide. Okay, did I cover them all? Nitrogen goes to nitride, oxygen goes to oxide, sulfur goes to sulfide, fluorine goes to fluoride, chlorine goes to chloride, bromide, iodide, and we forgot phosphorus. Phosphorus is here, so that'd be phosphide. Now, let's go ahead and play around with some of the names. So this is going to be fun. You can add these to anywhere on your notes if you like, or just add a piece of paper. But if we just have sodium and we have chlorine, well, let's first find its oxidation state. So I've got this clever, easy little cheat sheet here that is really helpful, and I recommend you take a look at it on Schoology. But here we have sodium. We know it's in the first group. It's got a +1 charge. And then chlorine is in the 7th group, and it's got a -1 charge. So we'll say +1 and -1. So it's sodium plus and minus. And what we're going to do is the two of them are going to come together. They're going to be formed by electrostatic attraction, and they're going to be NaCl. Okay? Now what has happened is that the positive charge has gone down, and the negative charge has gone down, and the positive charge has gone this way. Okay? So this is a +1 and a -1. So we now have subscripts of 1 down here. This will make sense in a second. So you have Na1 and Cl1 right here. So you could just call it, we drop the ones and we say NaCl. Let's try another one that doesn't work out so well. Let's say calcium. And calcium and bromine. Well, if you look at calcium, it's a 2+, and bromine is a 1-. So calcium's 2+ and bromine's a minus. Well, now you'll see that we need to bring them together, and we're going to need 2 bromines to cancel out a 2+ charge. Okay, so that's going to be CaBr2. Okay, what we're going to do is we're going to take that 2 and we're going to bring it down to this subscript, and we're going to bring this -1 and we're going to bring it down to this subscript. The ones are understood, so you see how that works. So that's going to be CaBr2. We would call that calcium bromide. We would call this one sodium bromide. Sodium chloride. Let's try one more just for fun. Let's look at this guy, Ag. Yeah. Now Ag, well, Ag is not on the left side, but Ag is silver. Okay, so silver is a transition metal. However, it is still a type 1 cation. There are a couple cations that will show up on the test that are actually transition metals that we will call type 1 because they still only have one oxidation state. So zinc has a 2 plus, and then silver has a +1 or a 1 plus. Okay, so silver has a plus, and then nitrogen, if you looked at it, has a 3 minus or a -3. Hopefully you guys are following that. So we'll take this, and we're going to take, that's a 1, and we're going to crisscross this, and we're going to get Ag. The 3 comes down here, Ag3, and the 1 comes down to be the subscript for N, so it's N. And we would call that silver nitride. Simple enough. Now you'll have to do it the opposite way. So what if I told you that we had silver iodide? Well, silver is Ag plus, we just talked about this, and then iodine is a minus. We crisscross them, or there you can see that this is +1 and this is -1. You guys are smart. You're pretty math savvy. You know that those would just come together. That would be AgI. All right. Now, if we look at magnesium oxide, we just got to look them up. We know that magnesium is Mg, and we know that oxygen is O. We look them up on that handy periodic table. We find that Mg is a 2 plus, and that oxygen is a 2 minus. Now we figure out something interesting. So that 2 comes down here, and the 2 comes down here. So should it be, Mr. Russell, Mg2O2? Probably not, since you're being so cagey, right? That is not correct. Not correct. Please don't write that. You should be writing MgO because we should reduce this to the least common denominator or multiple. If we take Mg, it had 2 valence electrons, and then oxygen had 6. Oh, I drew that weird. Had 6 valence electrons here. You would see that here, you would only need 1 magnesium for every 1 oxygen. So that's what this is saying. You need 1 magnesium for every 1 oxygen. Okay? See how that works? So that's where the crisscross method will fail you, all right, is if you don't reduce your charges. One last one just for grins. Zinc fluoride. So I threw in zinc again. Zinc, we know, is a transition metal, but it is type 1, so it only has a charge of +2. And then fluorine has a charge of minus or -1. And so that 2 comes down here, and the 1 comes down here. So we end up with zinc with the subscript of 1, we'll drop the 1, and then fluorine with the subscript of 2. Piece of cake. All right, that should get you through everything. Try these on your notes. Just for practice, I'm going to put the answers up in just a second. When you try these, you cannot do this one, and this one, or this one. Those are type 2.